What's going on, guys? My name is Johnny Bannon and I'm your CCNA instructor for this CCNA video series. And in this video we're going to go over our SSH lab, and this is going to dive into the actual configuration on the iOS CLI. So for all you guys viewing on YouTube, thank you for watching. If you are interested in any live virtual training boot camps for your corporation or government organization, please feel free to reach out on our website to see how we can do some in-person or live boot camps for you to further assist you with your CCNA studies. With that being said and getting that sales pitch out of the way, let's go ahead and jump right into it. So this is going to be another just quick, easy lab. What we're going to do, again, got to start this the same way I do every other lab, even though it's very simple. We're going to go over the instructions here on our GitLab. So it should be in the description below on our YouTube videos. If you come to section 6, SSH lab, you're going to see here the network diagram and then our instructions. So our instructions tell us that we got to turn on our devices. So in EVE-NG, you'll come over here to more actions and start all nodes. And for our paid viewers on our paid course or have gone to a boot camp through us, all these labs are available to you, already pre-configured with like some easy baselines. For those watching on YouTube, thank you for the support. We have YouTube videos going over how to set up EVE-NG just like this. So now we got that out of the way, let's jump into the lab. So we'll turn on all devices, then we're going to paste the baseline from GitLab. So we can paste our baseline to GitLab that I have posted here under the root folder of this Git repo. And then we're going to verify all connectivity and IP addressing. So here we just got to make sure that we configured the IP addresses on this one little link. And then from there, we're just going to jump straight into configure SSH on both devices. So let's do it. So I'm going to use secure CRT to jump into the CLI of both these devices. Let's get this nice and worked out. Get it expanded so we can see nice and clearly what we're typing. Put this in the middle of the screen. All right. So what we're going to do now is go ahead and start configuration. So this is blank. I didn't actually put a baseline in here because part of the baseline is configuring SSH. I mean, it won't affect the lab. You just redo the steps if you do post the baseline, but no big deal. So the first thing I'm going to do is go ahead and configure my IP addressing. And I don't know what this is in the way on the screen, but that's okay. So we're going to go ahead and configure the IP address. It's going to be 10.10.1, and it's at a /31, so that's 254, which is totally fine because it's our point-to-point link. Put a description to switch 1. Awesome. Going to go to the switch, do the exact same thing. So on the switch, when we go into interface 00, I'm going to put no switch port. This is going to make it be a routed port, which will let us do layer 3, which is what we need. We could have also created an SVI, but this works as well. Put the description to R1. Awesome. Now we're going to do a quick ping test. Make sure we can reach our other end. Great success. Went through that super quick, of course, because at this stage in your CCNA training, configuring IP addresses should be a no-brainer, right? It should be second nature. So now let's go ahead and go through with the SSH configuration. I'm going to configure this switch to be version 1. I'm going to configure this router to be version 2 of SSH. The steps are the exact same. The only difference is the bit key size, and I want to just show you guys what that looks like. So first thing we got to do is create a host name. This host name is important because this is going to be part of that fully qualified domain name that's going to be used for our RSA key pairs. And then let's go ahead and put a domain name. So we'll put tripletech.com. This could be anything. This could be test.lab. This could be lab.net. It's just needed to create that RSA key pair. Next, we're going to create our local credentials. So I'm going to do username Cisco, privilege level 15, which we'll go over what that means in later sections. And then set the password. We put secret here, and that's going to allow us to store this password not in plain text. And that's step 1. Now let's go ahead and generate our actual RSA key. So that command is going to be crypto key generate. If we look right here, let's see what options we have. We could also create elliptical curve keys. I think that's what that is for this key exchange. but we're creating RSA. And then we're going to have some options here. So we're going to create just regular RSA key pairs. So what we're going to do now is provide the bit size, the bit strength. So that's going to be modulus. And then here's the sizes we can do. So let's do 1024. Okay, so we went ahead and created our SSH keys. And you look here, are we using version 1 or 2? Let's go ahead and take a look with some of our verification. We're using version 1.99. So this key strength wasn't good enough for IP SSH version 2. So if we type this command in, IP SSH version 2, let's see if that changes it. And it does. Now we're using version 2, but I'm pretty sure the key size is still going to be 1024. So we can kind of go in and change it to version 2 using a less, a key bit size that isn't as strong. But now R2, let's go ahead and configure SSH. So first thing we're going to do is create that host name, which is going to be needed for that RSA key pair. Next, we're going to set a domain name. Actually, let's not, and let's see the error we get. How about that? Let's not do this either. Let's say we just have a host name, and now we want to create our RSA key pairs for SSH. Let's see if it's going to let us. It doesn't. It says, please define a domain name first. So now let's define a domain name. Is it going to let us? It is. Awesome. So we see that it let us create those RSA key pairs. So that tells us that the username and password isn't needed to create that RSA key pair. However, you need credentials. You need to have a username and password set to SSH to a device. So technically, no, a username and password is not needed for the RSA key pairs to be created, but it's needed for establishing SSH on your network devices. So we're going to go ahead and do that now. So let's type in username, Cisco, privilege 15, secret Cisco. All right. And now we are good here actually, because we already created the RSA key pairs. So I want to show you how we generate, what happens when we generate stronger key pairs or another key pair. So now we're going to do modulus 4096, the strongest we have. So it says the old keys are going to be replaced. Version 1's disabled. Pretty sure it's going to give us output that says using version 2 as well. And you see it's kind of taking a while, and that's because it's using a lot more computational overhead with this bit size than it would 1024 or 2048. You can see it's probably going to get stuck there. You know, I may have to reload the router. We'll see. But let's continue with the SSH steps. So now that the key is made and we see that, what do we need to do? We need to do line VTY 0 through 15. Maybe on this, we only got 5. That's okay. Login local, telling it to use the local credentials when we SSH. Then transport input and see all the remote protocols we can use. We just want SSH. So I'm going to put that there. But in the lab instructions, we also want to do telnet later to compare. So I'll put telnet too. But we need the transport input SSH to accept SSH connections. R2. All right. Looking good here. IP SSH version 2. Let's do our last step here. Do the VTY lines. Login local using our local credentials and transport input SSH and telnet. You don't usually want to do telnet. In this lab, we're letting telnet connections in because we want to see the differences on Wireshark. So now let's go ahead and do our packet capture. And let's do a telnet connection and SSH connection, then we'll compare the differences. All right. So first things first, we want to SSH to another device from our Cisco CLI. We're going to type in SSH, tag L, which means define a user, Cisco. So you may ask, well, what if we don't define a user? Will it work? Well, two things that go off of there. If you consoled in to the router, and you didn't use any credentials to console in, meaning you just consoled in, you have to define a user to use. Let's say you remoted into this device and you're now SSHing from this device to another device. So let's say I SSH from my computer into R1, and then I'm going to SSH from R1 to switch 1. I technically don't need to define a user. It's just going to use the credentials I use for this login. But it's always just kind of best practice too, because sometimes we'll be in a scenario where we're using TACACS credentials to log into this router. We need to remote into this switch that hasn't been fully onboarded to the network yet, and we may have to use local credentials. And in that scenario, if we're remoted in to this router with our TACACS credentials and we don't define a user, it's going to try to use those TACACS credentials to log into this switch, which is only using the local database. That ain't going to work. So in that scenario, you want to define a user. It's just always best practice. So that -L there means define a user, essentially. And then we're going to do the IP address. So 10.10.10.0, I believe. And we're going to see this here. So it should bring us up with a password prompt in just a moment. There we go. So a little real world note here. On Cisco iOS, how can I tell if this is using TACACS credentials, Cisco ICE, or any kind of authentication server for network authentication? I can tell from just this prompt, because you see this capital P here? That indicates on most iOS devices I've worked on in the enterprise that you're using local credentials, or you need local credentials to log into this device. If it's a lowercase p, if this capital P was a lowercase p, that means TACACS. Just a little nugget for you, right, of information. Because I like to bring that real world into this sometimes. So let's complete that SSH connection, especially I want to complete it when we're looking at Wireshark and we want to compare that in Telnet. So a little slow here, that's okay. Sometimes this does happen, especially in the lab. I'm going to put the password Cisco, and we're in. Now let's go to the switch. And what I'm going to do here is just put in the IP address, and that's going to do a Telnet connection. You could also just like say Telnet as well, but if you just type in an IP address and hit go or like a domain name and hit enter, it'll try to use Telnet to log in. So you notice the difference here at Telnet, it's going to prompt you for username and password initially, instead of SSH where it just asks for password. Now let's go to our Wireshark capture. Let's look at this. I got a lot going on here, so let's zoom in. Let's take a look at this SSH connection. So you can see SSH protocol here. You can see the TCP. So let's actually go, look at the client key exchange. So here we're actually sending the key. We can come down here to this SSH version here, key exchange. We can actually look at the algorithms that are being used. Diffie-Hellman. So we can see the servers exchanging that key back. You see we're using the TCP handshake here too, pretty cool. Then client is saying we want to use Diffie-Hellman. I'm just looking right here. So we do that Diffie-Hellman exchange, initiating it, and that Diffie-Hellman is going to be that secure exchange protocol that we're using for the public keys. Still doing that reply. Then it looks like here now we have agreed on what session key we're going to use. Right, new keys here. And then now let's look at that encrypted packet. If you look at that encrypted packet here, we can't see nothing. So kind of cool going through the sequence. What you saw there was that initial connection using that public key pair, using Diffie-Hellman as the key exchange. And then once they agreed on a session key to be used for their symmetric encryption, now we see that symmetric encryption happening on these packets. So anything I send via SSH, you can't see. Now if we come down here to Telnet, let's take a look at this cleared data. So we look at Telnet here. Let's go ahead and do, Telnet data. So we should start seeing like some characters here. Let me keep going down the line a little bit. Yeah, so here's our characters here, right? That we can see what data is being sent across the wire. Pretty sure that was when I was typing in exit. Yeah, exit. I mean, pretty crazy, right? So pretty much telling that you can do like almost a key logging attack. You can capture any clear text data coming across. You can figure out the password. Let me look at here. This definitely give me the password, username and password information. You can see client and server responding back to that telnet data. You can see it's typing out Cisco. And then we move on. That's the enter key. And then we type in Cisco again. So here someone could deduce the username and password we're using because telnet sends it in plain text. All right. So that's going to be it for our SSH lab. I hope everyone enjoyed the video and you learned something. And again, if you want any boot camps for your unit, organization, or corporation, feel so free to hit us up or go on our website and look at our virtual training schedule. We do Army CA funding, we do Vet Tech funding, and we look forward to working with everyone. And we look forward to you guys subscribing and liking this video. Thank you.